All right. Kind and considerate and cantankerous students of third period geometry. This is your, I don't know, fourth or fifth video. I've lost track by now. Anyway, this is called Geometry EOC Practice 21 through 40. It is spring of 2024, and I'm going on a trip next week, so these are videos to help you guys work the problems. Don't forget to put Geometry EOC Practice 21 through 40 in nice bold letters here, and then your name and date is always a nice thing for me to see on there. Really helps me to identify who that belongs to. All right, so let's get started. These I've already looked through, and they are not too bad. We'll be done with this one in about 10 minutes, I hope. Okay, so cylinders A and B have the same height. The radius of cylinder A is twice the radius of cylinder B. So let's say cylinder B is 2, and then cylinder A is 4. Then what we're going to do is actually, they have the same height. So we're going to actually plug in some numbers and see how the numbers compare so that we can compare the volumes. So volume of a cylinder is, volume of any solid prism is the area of the base times the height. The area of the base, in this case, the base is a circle. So we're going to substitute pi r squared for that area of the base, and then we still have the height in here. So that's what we're going to be solving for right there. But we know that r is twice the value. H stays the same. So if r goes from a 2 to a 4, then the volume goes from 2 squared in the equation, which is 4, to 4 squared, which is 16. That would be 4 times the volume of cylinder B. So it starts off, that one was not the easiest one in the whole bunch. It actually wasn't too bad at all. This one I'm not even gonna write on the board. The perimeter is 36. What is the length of the diagonal x? I better write on the board. I thought it was asking about the side, but it's the diagonal. So let's dive into this diagonal here. So this creates a 30, 60, 90. Oh, sorry, 45, 45, 90. I'm getting a little loopy from recording these videos today. 45, 45, 90 is right there. So if the perimeter is 36, there's 4 sides. The perimeter is just the addition of the sides. All the sides are equal. So we could do 4s equals 36 and solve for s, but we should know by now that 36 divided by 4 is just 9. And that in a 45, 45, 90, the side to the hypotenuse is times the square root of 2, because the ratio is 1 and the square root of 2. So we're going to go with 9 square root of 2 on that one. All right. Number 23, triangle JKL is translated 4 units left and 5 units up. What are the coordinates of the image of point J? So this is, the image of point J would go 4 units left, 1, 2, 3, 4, and 5 units up, 1, 2, 3, 4, 5. It's kind of rude that they put it off the chart. Or what I was thinking is this the image? And that's the pre-image. No, this is the image. They should have said what are the coordinates of image of point J prime. Maybe there is a prime up there that I just can't see. So we're going to go to -6, comma, and we're, instead of 1, we're going to be up 5 units, so 6. -6, comma 6, so C. Kind of rude that it's off the edge of that coordinate plane that they give us, but that's okay. 2 parallel lines, M and N, are cut by a transversal as shown in the figure. We've done a couple of these problems already. M and N are cut by a transversal T, as shown in the figure below. If the measure of angle 2, let's label this thing. Measure of angle 2 is 2x plus 7. That's the measure of angle 2. We don't know how many degrees it is, but we know that it's equal to 2x plus 7, whatever the heck that is, right? And measure of angle 7 is 3x minus 13. 3x minus 13. Oh my gosh, 2 and 3 are vertical angles. So what is their relationship? They are vertical angles, therefore they are congruent, they're equal, they have the same measure. So we're just going to set our values equal to each other, because we know that whatever angle 2 is, it's equal to whatever angle 3 is, and that's what angle 2 and angle 3 is. So I'm going to subtract that from both sides. That's going to give me an x on the right. I'm going to add 13 to both sides. That's going to give me x equals 20. But then let's ask ourselves, what does it ask? I haven't even looked. Does it ask for x, or does it ask for the measure of an angle? What is the measure of angle 7? Oh my gosh, doesn't even ask for a measure of one of the angles we were working with. So we got to plug our x back in. 60 minus 13 is 47. And then we ask ourselves, what's the relationship between angle 3 and angle 7? If angle 3 is 47, they are corresponding angles. They're both in the lower left of that intersection, so they are congruent. Remember, you only have two types of relationships in these transversals. They're either congruent or they're supplementary. They either add up to 180 or they're the same. Okay? These happen to be the same, and you're never supposed to assume that things are equal, but you can really tell by the way they're drawn that those are equal. They're open the same amount. They're definitely not add up to 180. So we're going to go with C, 47 on that one. All right. The following information is known about the quadrilateral. B, we have to draw it very carefully, and I don't know how to draw it. BC is parallel to AD. So A, B, C, D. A, B, C, D. I'm drawing it very quickly. A, B, C, D. BC is parallel to AD. Okay, the top and bottom are parallel. That doesn't mean that they are, it doesn't mean it's a rectangle. Don't try to make it something, just follow the rules. AB is not congruent to CD. AB is not congruent to CD. So one of them is shorter than the other one, maybe like that. We're going to move D out here. Okay? And CDA is a right angle. CDA. So then I drew it. So we're going to make CDA a right angle, and we're going to bring A out here a little bit and call it that. Okay? That's a right angle. Which true must be true? Is it a rhombus? No, rhombus has all four sides that are equal. Is it a rectangle? No, a rectangle has all four right angles, and there's no reason to assume that it does. Matter of fact, it definitely isn't, because these would be equal. Is it a trapezoid? Yes, I would call it a trapezoid. And then is it a parallelogram? No, parallelograms have opposite sides are equal. So we're going to call that a trapezoid C. All right, how much paper is needed to cover a rectangular bulletin board that is 29 inches wide by 37 high? Students, rectangles are length times width. Multiply that out, you got your answer. All right, a scale drawing, hopefully it wasn't more difficult than that. A scale drawing of a house is shown below. What's the best estimate of the area? Okay, we're going to think about this thing as two different triangles. That triangle right there has 20 of these 36 square foot areas in it. So that's 720. Use your calculator. That's 720 square feet. It has 20 times of those 36 square foot areas. So it's 36, 36, 36, 36, 36 times 20. Okay. This top one, a triangle is exactly half of the rectangle that sort of encloses it, or that it's inscribed within, although we haven't talked about inscribed figures this year yet. So we're going to say this triangle is 1, 2, 3, 4, 5, 15 of those units. So 15 times 36, 15 times 36 is 540. We're going to call it half of that, so 270. We're going to add these two together and get 270 plus 720. 990, or we're right at 1,000, because it does say about, okay? All right, the area above represents the needle. The needle is rotated 180 degrees in the opposite, in the clockwise direction. Clockwise, counterclockwise, doesn't matter if we're going 180 degrees. What are the coordinates of point A after the rotation? Okay, no problem. So we're gonna go all the way around here. I always have to remind myself, what's the rule? What's the rule, Mr. Pierce? What's the rule? So I'm gonna use a simple example here. 1, 2, 3, 4, 5, 1. If I rotated that 180 degrees, it would end up over here at -5, -1. So both, we're just making them both negative. So -6, -8, -6, -8. We're gonna go with C on that one. All right, C, there it is. Frances bought a new refrigerator to replace her old. Her new refrigerator is the same length and width as the old refrigerator, but it's 8 inches higher. How many more cubic inches of space are in the new one compared to the old one? So we need the amount of the old one and the amount of the new one. So here's her old refrigerator. Multiply 30 times 36 times 62. There's the volume of her old one. Now we're going to add 8 inches higher, and we're going to figure out the new one. So the difference is just that 8 inches. If you want to think about it as just a single box, the new refrigerator is just this 8 inches times both other measurements. So there's the difference right there. 8 inches times our 36 times our 30. Or we could calculate them both and multiply them. So 8 times 30 times 36. We've got 8,640 units. square inches. Cubic inches, sorry, that's volume. A cereal box is 10.4 inches high, 7.4 inches long, and 2.3 inches wide. What is the volume? Volume is base times width times height. That is of a rectangular solid. Unfortunately, on your EOC reference sheet, the only thing they tell you is a right prism. So volume is the area of the base times the height, and it does explain that, but the area of the base varies depending on what kind of figure it is. This kind of figure is a rectangular solid or rectangular prism, so the base is a rectangle. Now it doesn't matter what you call the base, the bottom, the left side, or the top, as long as you do it correctly. We're just going to multiply the three numbers together. So 10.4 times 7.4 times 2.3, and we're done. We have all the same units, so we're at about 177, or C. John measured the sides of 4 triangles. He measured the side lengths of one incorrectly. Which triangle was measured incorrectly? Any triangle, I don't have my, let's see. Any triangle, no matter how flat, let's look at a very, 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 very flat triangle, okay? If this side is 10, those top 2 sides have to add up to more than 10. Because if that was 5 and that was 5, that it would just fall down. That would be the same length as the bottom of that thing or as the base of it. So those 2 sides, the other 2 sides, have to be greater than that third side on the longest side. So this one's the one that doesn't make sense. 2 sides add up to 6, the bottom side's 15. That would look like this: 15, 6, 6. It doesn't make a triangle. There's no way you can make a triangle out of those 3 sides. Those 2 shorter sides have to add up to more than the longest side. So we're going to go with A on that one. Okay, 9 more to go. We're at 12 minutes, not bad. Marie created a circular window represented below. She knew that 1 and 2 are supplementary. Always tell yourself as you're reading, what does that word mean? Supplementary means adds up to 180 degrees. So supplementary, add up to 180. So 1 and 2 add up to 180. Okay, that tells you that that's a line. No big deal, okay? NBD. And that 1 is congruent to 3 because they are vertical angles. That makes sense. We know that vertical angles formed by intersecting lines. What must be true about 2 and 3? If 1 and 2 are supplementary and 1 and 3 are congruent, then 2 and 3 must be supplementary as well. Okay, they have to be supplementary. So we're going to go with C on that one. Yeah, a lot of you might accidentally put 2 and 3 are congruent, but remember, it doesn't tell us. It tells us that these are supplementary, and I know they look like they're 90, but this is a case when you cannot assume that. Really can't assume that. This could be 89 and that could be 91. In which case, this could, 1 and 3 would be 89, and 2 and 3 are still supplementary, okay? So plug in some values if you need to. Ask yourself some questions to work the logic out. It's easy to assume that these are right triangles, but nothing tells us that. We just know they add up to 180. For all we know, this could be 30 and that could be 120. Wait, 30 and 150. It's not drawn that way, but it could be, okay? We cannot make assumptions. Okay, so we're going to sell juice in boxes represented by the figure. What's the total surface area of the box? We're going to go over here and go to our right prism. Surely we have, yes, look, rectangular prism, also known as a box. Rectangular prism, we're going to add up our length times width, height times length, height times width, and then multiply it all by 2 because there's doubles of each of the sides. Right? So it's basically length times width 6 times. So we got to add up the front side, this red part. That's going to be 110. That's 10 times 11. And then there's a back part of that also, okay? So that's 110 and 110. Then we're going to do the right side. That's going to be 5 times 11, so 55 and 55. 55 cubic and 55 square centimeter, 55 square centimeters because there's one on the left. And then we'll do the top and the bottom. Top, and then the bottom is, of course, right here. And that's going to be 10 times 5, which is 50. There's our 6 sides. Add them up. So 110, 3 plus 100, so 430 it looks like, C. Okay? All right. Just a few more to go. The equation of the circle is this. Which represents this equation? I learned, dear students of third period geometry, I learned on the last video that, because I haven't reviewed this in a long time, haven't done conics in forever, because they weren't on our EOC last year, and actually they're not this year, but we can look at it, that it's the center of the circle is opposite and opposite of what is in there. So our center is going to be -2, -3, and that one matches D. All right? D is our answer there. Okay, 35. Joe's garden is in the shape of a hexagon. Hexagon is six-sided. So 1, 2, 3, 4, 5, 6. There's our six-sided figure. The measures of 5 of the angles, we don't have to label them. 160, 90, 60, 160, and 80. So what is the third? It doesn't say a regular hexagon, and I drew a regular hexagon. Don't let that throw you off, okay? These are not all equal. Clearly they're not. It tells us that they're not equal. What is the measure of the remaining angle? Well, how many, what is it? What do they all add up to? That's the question. What do all the angles in a hexagon add up to? So that all the angles in a polygon add up to that 180, not 18, Mr. Pierce, 180 times n minus 2. So this one has 6 sides. N is the number of sides. So 180 times 4 is 720. So they all add up to 720. Now I'm just going to subtract each one of those angles, and the difference will be the angle that I want. 170. Boom. D. There we go. All right, 5 more. Sean has a greenhouse in the shape shown in the figure below. He keeps new plants in the room represented by the shaded area. What is the perimeter of the room that is shaded? This is not a bad problem at all. You just have to look at your verticals and your horizontals, because if it's rectangular rooms, then you know that the opposites are parallel and opposite sides are equal and that sort of thing. So that means that this part, if we were just to come down to that far, is 15. And we know that this part is 10, because this is 10. So that whole side then is 25. And because this is 40 and that is 28, we can subtract to figure out this portion right here. So this portion is 12. So we have 4 sides, 2 of them are 12, 2 of them are 25, and we just add those up. So 50 plus 24, 74. We're going to go with A on that one. All right, and 37. Measure of ACB is 45. Now we're just getting into this, students. We're just getting into sectors and central angles and stuff like that, so we haven't covered this yet. But we're just going to set up our proportion, all right? Gosh, you hear proportion a lot in geometry. It's like we should remind you about proportions before you go into it, but actually we have in the last 4 years of your math class. So the measure of ACB is 45. So what portion, if it's 360 all the way around, what portion is that central angle of 45 of the whole circle? Well, we could set up a ratio of that. So this represents the proportion, the portion of the circle that central angle represents, 45 out of 160. And then we just multiply that by pi r squared, or the area of the whole circle. So the area of that shaded portion is the angle divided by 360 times the whole circle, okay? So R is 7 inches, so we're just going to do our 45 over 360. And I don't even remember, students, if this is the actual formula, but I know that it is a formula that works. All right, so we're going to end up with 19.23, or A. There we go. All right, 3 more. Which three-dimensional shape can be formed from the net below? If you've ever wrapped a gift, especially a shirt box, you kind of recognize this. You know what we're talking about. Or work for Amazon for sure. Which three-dimensional figure? So we're going to talk about, it's a prism. It's not a pyramid, it's not a cube, and it's not a cylinder. A cube is all 4 sides, all 6 sides are the same, right? So we're talking, it's a rectangular prism or a box. Okay, so we're going to go with C on that one. Figure MNOP is an isosceles trapezoid, and figure MNOR is a parallelogram. So that's a parallelogram. That means that that side and that side are congruent, okay? And the trapezoid is, let's see, let's go with green on that one. the trapezoid is this part. That's the trapezoid, and it's an isosceles trapezoid, so that means that the two non-parallel sides are equal. So that side is equal to that side. Well, if this side is equal to this, and that is equal to that, then this is an isosceles triangle also, which means that the bottom, the angles across from the equal sides are equal. So if MPR is 62, then this angle is 62, and we subtract both of those from 180, and we have our angle up here of 56. All right, so that top angle is 56. So work the logic out on that and make sure you understand it, because so much of geometry is not just learning the shapes and it's learning these relationships and then being able to work out what is true and what is not true based on all these angle and side length relationships. It's a lot. Right? But after a while, if you practice it enough, it starts to make sense. So what is the value of x? So we can't use Pythagorean theorem because we would need to know this side here. So we're going to talk about the angle 45. Well, it's a 45, 45, 90 because if you subtract, you realize that has to be 45. So that means this is 12 also. And then on a 45, 45, 90, we multiply by the square root of 2 to get to here. So it's going to be 12 on the square root of 2. And that finishes up 21 through 40. And you would think that the next section we're going to do is 41 through 60, but apparently I lost that one. I don't know where it is. I'd have to talk to a couple of the other geometry teachers and see if maybe I sent it to them. So anyway, we'll pick up with 61 through 80 here in just a few minutes, all right? All right, good luck.